how this manifests. So I'm going to go through this list to see that we understand the rules. And if you want to pause it right here to go through this list yourself, I would recommend that. Okay. So I'll start by saying if I have n equals 1, that's the very beginning. Okay. I can only have one possibility for L. That's L is equal to 0. And my sub-level, I haven't introduced this yet, but my sub-level I would call 1s. Right? Remember, because when L is equal to 0, we call that S. And based off of n, our sub-level designation becomes 1s. And I only have one ml number, 0, that's based off of L. And that means I only have one orbital. And that orbital is called the 1s orbital. Okay? So I'll draw an arrow to that and say that's called the 1s orbital. Okay, so now what if I go to level 2? So I've got n is equal to 2. So that means now my possibilities, I could have L is equal to 0, but I could also have L is equal to 1. Okay? If it's L is equal to 0, I call this 2s. That's still an ml number of 0, which is one single orbital. And so I only have one 2s orbital. Okay? But now what about when I have n is equal to 2 and L is equal to 1? Well, when L is equal to 1, that's called P. So I call that a 2p. Okay? And now my ml can be -1, 0, or +1. So that gives me 3 orbitals. And as we shall see, there are 3 2p orbitals. So I'm going to say 3 of them. There are 3 2p orbitals. Okay? So let's keep going with this. So now if I have n is equal to 3, I can have L is equal to 0, 1, or 2. If it's 0, that's called 3p. And as you might have get 3s, 3s, that's an ml equal to 0. So of course there's only one 3s orbital. However, when I have 3 and 1, that makes 3p. And there's -1, 0, and +1. So that's now 3 3p orbitals. Okay? What about 3 and 2? Well, when L is equal to 2, that's called a d. So now that's 3d. Okay? And now my ml values become -2, -1, 0, +1, +2. That's 5 numbers, 5 orbitals, and there are 5 3d orbitals, as we shall see. Okay? And so the last one I'm going to do on this example, when n is equal to 4, we can have 0, 1, 2, and 3. And as you might have guessed, that's going to be 4s, 4p, 4d, and finally 4f. Okay? And I'm not going to write all the ml numbers, but it's the same pattern, right? There's 1 4s orbital. There's 3 4p orbitals. There's 5 4d orbitals. And there's 7 4f orbitals. So I've got all of that summarized right here. Okay? So now, with the last little bit of time in this lecture, I'm going to describe how these numbers make up addresses on the periodic table. Because for now, we haven't identified any of these as an individual electron. Rather, these are just the possibilities. Okay? It's kind of like listing, all of the states and then listing all of the cities in the states and then listing all of the possible streets in the states and then listing all the possible addresses in the states and the cities and the streets. So that's what we've done so far. We've just listed all the possibilities. Okay? So how do we map these onto the periodic table? Well, here's how we do it. Okay? And you need to know this. You need to know how these orbital sublevel designations So in other words, the 1s, 2s, etc., how they map out onto the table. Okay? So first, let's start by noting that these numbers right here correspond to n, the principal quantum number. And look, 1, 2, 3, 4, 5, 6, 7 is where it stops. 7 is our max for n. And notice that they go across. They make the periods, right? So n is equal to 1 goes all the way across. N is equal to 2 goes all the way across. 3, 4, oh wait, but something funky happens right here. So let's back up and talk about that. And I also want to talk about what we notice here is you can see that there's actually 2 blocks for 1s. Okay? Hydrogen and helium make the weird example because, right, you want helium to be over here, but because it's a noble gas, it appears over there. But we really recognize helium is in the 1s block. And if you now look at the rest of these, look, 2s, 3s, 4s, 5s, 6s, 7s. This makes up our s block. Okay? The s block. So now, and you notice that there's 2. And you'll see why there's 2 in a moment. Okay? So now when we go to the p's, we don't have a 1p, and that's correct. Remember, right, when we started with n is equal to 2, it goes 2s, 2p. We don't have a 1p level. It starts at 2p. And then look, we have 2, 3, 4, 5, 6p, and it stops at 6p. Okay? And you also notice that we have 1, 2, 3, 4, 5, 6 p spaces for the p block. We're going to see why that is in a moment. Okay? And then now you notice here we don't start at 1D or even 2D. We start at 3D, and that's because of the way this level 3 works out, right? 3s, 3p, 3d. And we go 3D, 4D, 5D, 6D, but we stop at 6D. And if we were to count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces on the D block. Okay? And then finally, the lanthanides and the actinides make up the F block. And notice it starts at 4, and we only have 4F and 5F, and that's it. And if we were to count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces on the F block. And I want you to remember these numbers that we came up, right? So we noted that for F, there was 14 spaces. For D, there was 10 spaces. Oh, and this is a mistake right here, sorry. So 4, 0, 4s, that should be a 1, okay? So we noticed when there was, for P, there's 6 spaces, and for S, there was 2 spaces. So can you see the relationship? So it's times 2. Why is it times 2? Because plus 1/2 or minus 1/2. So there becomes 2 possibilities for each space. And so here is what that looks like. So check it out. So here I've put now finally the addresses. So you've got the full thing. So you've got city, state, street, and house number on this periodic table, right? Awesome. So we can see here, n is equal to 1. So n is equal to 1 only corresponds to these 2. The ml is equal to 0, and it can be ml, so it can be 0 plus 1/2, or it can be 0 minus 1/2. That's where I get 2 spaces. And now when I go down to the next S block, n is equal to 2, I can have 0 plus half or 0 minus 1/2. 0 plus 1/2, 0 minus 1/2. 0 plus 1/2, 0 minus 1/2, etc. That's why we see 2 spaces per S block. Awesome. Okay, well, what about the P? Well, now check it out. It goes -1 plus 1/2, -1 minus 1/2. 0 plus 1/2, 0 minus 1/2. 1 plus 1/2, 1 minus 1/2. So there's my 3 ml numbers, -1, 0, and 1, times 2 for each plus 1/2, minus 1/2, to give me 6 spaces in the P block. And as you can see, so I'm calling them block, but shell is also okay. So block and shell are used interchangeably. So now D, right? This is the last one I'll go through. But you can see -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. It all adds up to 10. And if I were to do this with the F block, that's where we would get the 14 spaces. Okay? So that's where I'm going to end it for this video. So that's basically describing